Okay, welcome everyone to Unilock's 2022 UTech Virtual Specifier Education Series. My name is Dave Robbins. I'm going to be your host and moderator today. Just wanted to say a quick thank you to everyone that's joined us. With the weather outside today, it's kind of nice to have this technology to go to. We're not all trying to find a snow clearing in a parking lot somewhere. So we just had a few housekeeping things to go over before we get started. We're going to be questions you can ask in the chat forum that's on the right side of your screen. And what we'll do is we'll save those questions until the scheduled question time after the presenters speak, and then we'll wrap that up with some questions at the end as well. So just to start things off, our commercial sales manager Dave Laurie just had a few words he wanted to say.
Hello, my name is Dave Laurie, Sales Manager, Commercial Sales, Unilock Canada. I began at Unilock in 1997 during Unilock's 25th year in business. This year, Unilock is celebrating its 50th year in business. Unilock began with one paver named Unistone, available in a single color. We now have a 170-page catalog featuring a large variety of products. When I began at Unilock, I was one of 5 sales reps in Canada. We now have 18 sales reps, including our newly added Quebec business operation. Our sales have grown significantly, and the size and number of production plants have also increased, both here in Canada as well in the US, centered around the Great Lakes. Unilock began with commercial projects in 1972 with the Unistone, then grew tremendously in the residential marketplace, becoming a significantly well-marketed household product name for many years. Approximately 20 years ago, Unilock began to renew our focus on the commercial world of spec build projects. Sales rep like myself in Ontario, as well in New York and Chicago, moved from an all-round sales rep role looking after both residential and commercial business to a focus on commercial work only. With a high level of focus on commercial work, the emphasis was on getting Unilock specified by architects, landscape architects, and engineers. This led to a significant focus on doing lunch and learn presentations to this audience, working hard to become the most sought after company for commercial projects, product supply for pavements and retaining walls. Like the lunch and learns that Unilock sales reps have presented for many years now, the company's long-term objective is to provide the most current information to ensure all the best practices are being followed in both the design and construction of the systems that Unilock products are used within. Unilock understands that not only do our products need to be of the highest quality, but the partnership between our firm and yours in working towards high quality installations is of the utmost importance. We are proud to bring to all of you our 2022 UTech Virtual Specifier Education Series. Thank you.
Okay, great. So this is part 2 of our education series. You may have attended the Permeable Pavements with Alex Bortolo yesterday. Today's topic is going to be successful streetscapes, unit paver design, and construction best practices. It is available for OALA credits and OAA credits. There'll be a survey in the chat area that you can take. It'll also be emailed to you after the presentation, which you'll be able to fill out, and a learning credit will be sent to you. It qualifies for 1 hour. So I'm just going to begin with a brief history of Unilock, followed by some recorded segments with Danny Gatto. Unilock is a proudly Canadian company founded by Ed Bryant, and the Bryant family still are the decision makers today. They continue to guide the company and make Unilock successful. 2022 is a pretty special year for us. It's a milestone. Unilock is celebrating its 50th anniversary. We were the first manufacturer of concrete unit paving in North America, and we continue to bring new and exciting pavers to the market. We are a Canadian company with our first operation beginning in Barrie. We've since expanded Canadian operations to in Ayr, Gormley, Pickering, and Georgetown. And most recently, we've added operations in Quebec. We also have a number of US locations in Boston, Chicago, Cleveland, Detroit, Milwaukee, and New York. We source local materials to manufacture our products, helping the communities we operate in. We're environmentally responsible in our manufacturing processes. We manufacture quality products by producing unit paving, wall blocks with precise dimensional tolerances, low absorption rates, and high compressive strength. All of our products meet, but more often exceed all industry standards. Unilock is a trendsetter and drives the unit paving and retaining wall industry with new and innovative products. We are proud to be one of the go-to choices for designers when specifying unit paving and walls. So thank you. Just going to have a quick look at our team. We have a large commercial team of professionals across Unilock locations across North America, all ready to assist you in any of our commercial team. We have 65 territory managers serving contractors and dealers in your area. We actually have David Roscoe, who's joined us today from the US, from our Ohio market. So for any of our American friends that have joined us today, if you have any specific questions on the US, then please feel free to ask Dave. Locally, in the GTA, we have a dedicated commercial sales team servicing the design community, engineers, commercial contractors, with a focus on the GTA. We have, along with 4 territory managers, looking after the outlying areas of Southern Ontario, from the Golden Horseshoe to the Ottawa region, and all the way north to the Georgian Bay region. We also have 3 project administrators to support our Unilock commercial team. Here's just a look at some of our locations, or all of our locations rather. We have 18 manufacturing facilities and spread out across 13 locations in Canada and the US. So for our seminar outline, we've done our introduction and a few words from Dave Laurie. Next, we will be hearing from Danny Gatto, who will review unit paver standards, technologies, product review, and Unilock Resources. Our guest is Lori Schaus from ARA, and she will present on designing a successful streetscape and best practices. Following Lori's presentation, we'll have our question and answer period. Here's our contact info for Danny, who's obviously the speaker, and myself, the moderator. If you have any questions or at all during or after, please feel free to reach out. This is our speaker, Danny Gatto. Danny has been with Unilock for 5 years, but has over 20 years of experience in the construction industry and building services industry. Also, he is a technical representative with Construction Specification Canada. I'm now going to switch over to Danny's presentation on Streetscapes installation.
Hello, my name is Danny Gatto. I am a Commercial Territory Manager at Unilock, servicing the Greater Toronto Area. During my segment, I will be going through a quick review of the following: manufacturing standards, finishes, product customization, shapes and sizes, design considerations, resources, followed by a case study and a brief question break before getting to our guest speaker, Lori Schaus. Manufacturing standards. ASTM standards require unit pavers to have an average of 8,000 pounds per square inches of compressive strength, with a minimum of 7,200 pounds per square inches. The standards also require that pavers maintain an absorption average of 5% with a maximum of 7%. Height tolerances cannot be greater than or less than 3 millimeters of the intended height of the unit paver in order to comply with the standard. At Unilock, quality is paramount, and our standards are even greater than those the ASTM requires. Finishes. In order to specify concrete unit paving products, you must have an understanding of what is available on the market. So we will briefly discuss some of the finishes Unilock has to offer. Classic. Our classic finish is tried and true. It is frequently used and provides you durable and familiar option when working with tighter budgets. These products utilize a traditional product mix of large and small aggregates that are consistent from top to bottom with color mixed throughout. It is commonly referred to as through-mix concrete. Endura Color. Unilock introduced Endura Color or face mix technology in 1992. Endura Color is a two-step manufacturing process that combines a base of coarser aggregates for a stronger foundation with a concentrated color and wear-resistant finer aggregates on top. This technology allows us the ability to offer a range of unique textures and colors. The top of the paver also has a finer finish, so larger pieces of aggregate are not visible. Elegance. Our Elegance line is made using wet cast concrete, whereas other products use a dry casting method. By wet casting the pavers, we are able to offer seamless textures and colors. Our Elegance collection offers styles you can't get anywhere else. Additionally, our wet cast concrete unit pavers have a higher compressive strength for even longer lasting pavements. Here are some of our notable Endura Color finishes: Umbriano, Series, 𝐬𝐨𝐵, to name a few, along with our new Granito and shot blasted finish Rivella. We have a broad selection of unique architectural paver finishes to make your project stand out, or as we like to say, make it uniquely Unilock. Customization. Unilock allows you to customize products to suit your project's needs. Our vast array of sizes, edge details, finishes, and color options make it easy to achieve your design vision. Of course, minimum quantities would apply, so speak to your Unilock representative about the custom options available in your market. Shapes and sizes. Unilock can produce product in a large selection of shapes, sizes, and thicknesses, from slabs and squares to numerous rectangular and plank paver options. We have random bundles in varying size configurations. We also have geometric shapes and a large selection of permeable paver options. We regularly add paver molds to our collection as needed, and usually is dictated by a designer's need for a specific size and shape. Reach out to us for more information. Design considerations. Equally important to loading considerations are the laying pattern and aspect ratio of unit paving. When designing a unit paving system, we recommend, when possible, a herringbone or double herringbone pattern for areas that will receive vehicular traffic. Aspect ratio is a relationship between the thickness of the unit paver versus its longest side. A general rule is, for heavy vehicular loading, a 3:1 aspect ratio should be maintained. For light vehicular loading, a 4:1 aspect ratio, and all other paving sizes are considered to be pedestrian only. Other specialized pavers such as our Optilock, Bronte Street Paver, and our new Load Lock Paver are excellent for heavy vehicular loads due to their specific lock-up technology features. Of course, when in doubt, consult with your local Unilock rep and we can go through all the options available. Another consideration would be to design your pavement using a reinforced pavement structure. DriveCell is a reinforced soil structure product that enhances the performance of a pavement structure. I'll now play a short video from 𝐦𝐨𝐬 to further explain how it functions.
The addition of DriveCell within pavement structures maximizes the strength, stiffness, and resilience. To help understand this, we will discuss how pavements fail, how DriveCell works to prevent failures, why this is important, where we can use DriveCell, and the benefits that DriveCell provides. Pavement structures are strong in compression but weak in tension. They can fail in different locations, from different causes and mechanisms, but ultimately they fail in tension. DriveCell stiff geocells strengthen pavement structures by combining the best of both worlds from geogrids and flexible geocells by reinforcing and confining. This results in the maximum strength, stiffness, and most importantly, resilience for flexible pavement structures. DriveCell can be used in the base layer on decent subgrades and directly on weaker subgrades like a snowshoe to reduce the pressure on the subgrade. DriveCell can be added into conventional unreinforced pavement structures to significantly increase their strength and performance. Or you can take advantage of the strength increase by reducing the thickness to reduce the excavation and granulars while maintaining a similar or greater strength when compared to the original unreinforced section. Here is a comparison of the wheel load distribution for a flexible versus rigid pavement. In a flexible pavement, DriveCell maximizes the stiffness to increase the load distribution and maximizes the resilience to increase the durability. Together, these maximize the performance lifespan. Ultimately, this reduces the maintenance costs and minimizes the life cycle costs. For permeable pavement structures, the base and subbase are typically composed of open graded granulars. The design priorities are structural first and then drainage. A rigid and impermeable concrete base layer is a mistake under a flexible and permeable concrete paver's driving surface. The concrete should be replaced with DriveCell. As shown on the very right, 2 layers of DriveCell can be used in pavement structures, one on the base and one on the subgrade to further increase the reinforced strength and minimize the excavation and granulars. The original concrete base for this driveway was replaced with DriveCell. DriveCell can be used on the roofs of parking garages to improve performance, especially at transitions and to reduce the weight of the granulars. Tension cracks typically form at transitions from one type of pavement to another. Installing 2 layers of DriveCell along the transition helps smooth the transition and prevent cracking. Too often, pavements and curbs break up around catch basins. Installing DriveCell helps tie this area together to reduce costly repairs. Pavement structures often deform and crack over culverts. Installing DriveCell under the culvert helps spread the load and reduce the excavation required. Installing another layer above the culvert in the pavement structure helps prevent deformation and cracking. DriveCell maximizes the long-term performance of pavement structures for maximum benefits. During construction, the excavation and granulars can be reduced. Plus, the installation is quicker and easier. This results in overall time and cost savings. Maximizing the resiliency maximizes the durability. This means more wheel passes, less maintenance, and smooth transitions. Finally, using DriveCell has direct and indirect environmental benefits, including reducing export and imported materials, reducing truck traffic and related air and noise pollution, all while reducing the overall carbon footprint. Thank you very much.
Unilock Resources. As mentioned in the introduction video, we have a strong support system at Unilock. We have a growing number of territory managers in Canada and the US ready to assist you. To go along with the boots on the ground, we have a wealth of online resources available on our website. Our website is constantly updated and is segmented into 3 target markets to better assist you. Our contractors section, our home builders / homeowner section, and of course our architects and engineers section, where you will find helpful resources like product specification, numerous project images, cross sections, and hatch patterns, to name a few. Our 2022 commercial and residential catalog of dreams are available for download on our website, or you can request a printed copy. For the case study, we will be reviewing this amazing precedent project my colleague David Robbins worked on, Dundas Place, located in London, Ontario. The City of London had a vision to transform Dundas Street into Dundas Place, a public space and cultural hub to encourage residential intensification in the core, showcase built heritage of the area, and shape the downtown for decades to come. Dundas Place Streetscape was featured in Landscape Architect and Specify Your News magazine in 2021 and is an excellent example of a flexible street or flex street. A flexible street requires a unique approach to design that balances the needs of the various types of road users. In 2015, the city completed a new plan for the downtown, Our Move Forward, London's Downtown Plan, transforming the first 5 blocks of Dundas Street from the Thames River to Wellington Street was identified as the #1 transformational project, both in the plan and in the focus and goals set by the council. Dillon Consultant Limited was retained to undertake the environmental assessment study as the next step towards implementing the vision. Dillon also provided the overall design, planning, and engineering expertise to turn Dundas Street into a flexible environment that is shared by pedestrians, cyclists, and motorists. While Dundas Street is intended for vehicular use with two-way traffic and a streetscape that accommodates community events, converting into an outdoor venue for entertainment, music, and festivals, design elements such as wider, curbless sidewalks, narrower roadways, and reduced fixed elements support the flexible conversion of the street into a closed-off pedestrian plaza that can serve different functions for the community depending on the time of day. The widened sidewalks are also conducive to businesses expanding into the street. Other flexible design elements lend themselves to streetscape placemaking, including the movable bollards, which can be removed entirely so that the priority can easily be switched between pedestrian amenity and vehicular support. There are no parking meters. Parking is paid by an app, eliminating permanent structures. Minimizing fixed vertical elements such as street lamp standards create fewer obstacles impeding special event use when the road is closed to vehicles, while improving accessibility and helping define the separation of vehicle and non-vehicle uses. Furniture and planters used in the design can be moved or switched out as required. All of the elements thoughtfully create an engaging space with the ability to transform itself. The design emerged from the vision to replace the pre-existing traditional concrete sidewalk and asphalt roadway treatment with a uniquely designed interlocking concrete paver surface. The pavers allow for a seamless transition across both the vehicular and pedestrian areas, while providing roadside safety, accessibility, and engineering requirements. Unilock was a brand of choice because of our expertise, customer service, and the ability to meet the design criteria by offering the textures and colors desired by the designers. Thames River, a waterway that flows through the city. It was a major hub of activity and played an important role in the history and development of London. With a desire to use Dundas Place as a gateway linking the downtown core to the riverfront, the river itself became the inspiration for the wave paving pattern meandering down the center of the street. With such a detailed pattern, it was important for Dillon to team up with their Unilock rep, David Robbins, to further develop the wave-like pattern and to assist with any details. Unilock, was able to share our expertise through various collaborative efforts, including touring our manufacturing plant, reviewing completed projects of similar nature, to name a few. With durability and accessibility key design factors to consider, a custom color palette and detail pattern could easily be constructed with minimal direction once on site. The various paver sizes, styles, surface textures, and colors help to define the pedestrian areas from the vehicular areas in a safe way. To ensure the long-term durability, the pavers were installed over a concrete foundation. Over 700,000 interlocking paving stones were laid in a herringbone pattern at Dundas Place. This laying pattern, combined with the base detail and the aspect ratio of the paving stones, are key design considerations when designing for vehicular movement, allowing the paving surface to support both pedestrian and heavy-duty car and truck traffic. Here are some of the unique features of this flex street. The paving pattern mimics a river. No curbs, making it great for accessibility. Textured pavers delineate the pedestrian zone from the vehicular roadway. Removable objects, including seating, bollards, planters, and some of the lighting. Dundas Place has already proven the extent to which the program fulfills the vision set in London's downtown plan to make Dundas Street into the most exciting street in London. Dundas Place was not just a street reconstruction project, but is part of a long-term strategy to re-envision downtown London. Dundas Place is a dynamic and inviting destination in the city and has become the benchmark for future flex streets in Canada.
That's great. Thanks very much, Danny. So just at this point, we've got some questions. Cameron has asked, Unilock has been a favored product by the industry and designers due to the product range offered. In recent years, we've observed that Unilock has been undergoing some updates to product availability. How can clients/governments ensure that products are specified are available for major capital projects, even the design 2 to 3 years prior to construction?
Great question. And as many of you know, this question, I know the person that is asking it. For these large capital projects, we will make time, we will listen. Of course, minimum quantities do apply. As a business, we do need to update our product selection. So just keep in mind certain products that are considered standard or stock offering that are published in our catalogs and online, we go further than that. So there are products that we can make through special order or custom runs. And again, if it's a huge capital project, we had some local projects here in Canada where they're multi-year projects. We're not going to leave the designer, the client, the owner, the municipality hanging and not produce the product. Again, reach out to us for more specifics, and we like to call those, project-based decisions. So we won't, we want your business, and we're not going to leave you hanging, so to speak. Hopefully that answers.
Awesome. Thanks, Danny. That's also, it's important to keep in mind that, we were very strapped, as everybody was in the construction and most industries by COVID, and had to make a lot of on-the-fly calls. Unfortunately, having to sideline some products just to keep up with the overwhelming demand. Mostly residentially, I think everyone was looking out their back window, looking for ideas and projects to do. So we have tried to keep up as best we can with production and offering new and unique products. But Danny makes a good point. Custom is always an option.
Perfect.
Thanks a lot, Danny. So now we're going to move on to our guest speaker, Laurie Shaw. Laurie is a senior pavement engineer and transportation operations lead at Applied Research Associates. I won't read her impressively long list of skills and achievements. Suffice to say that she has a She has 15 years of experience in pavement technology and design, as well as managing in field operations and investigation. Lori holds both a master's and bachelor degree in applied science from the University of Waterloo. We're really happy to have her with us today. Thanks so much, Lori. I'll throw it over to you.
Thank you, David. Thank you for having me. All right, welcome everyone. Thank you so much for joining us. Today, I'm going to talk a little bit about some of the best practices for installation and design of both conventional and permeable interlocking concrete pavements. Again, if you have any questions, you can put them in that chat box and I'll try and answer them if I see them right away or at the end of as well. There we go. So today I'm just going to go a little bit about, show you a couple examples of what conventional and interlocking concrete pavements are for those that may not know. I'm going to go through a little bit of really basic pavement design and what we do as designers and what we're looking for. I'm going to talk a little bit about some of the bases and sub-bases that we use to support our pavements, and then some of those key features that we want to talk about, the materials and installation. And then we're going to talk about best practices, which is really what I'm going to show you is a bunch of pictures of what not to do, and hopefully we can learn some things here. So I have a lot to cover, so I'm going to touch on just some key points. There's lots of information out there to help you if you want more details, or we can discuss in the questions and answer the period at the end, or we can discuss offline as well. So again, I'm just going to kind of run through some stuff a little bit quick, but I hope you'll learn something. So again, I want you to understand just a little bit about basics of pavement engineering and what we do and what we're thinking about when we have to, to design these systems. Understanding the importance, particularly when we're talking about interlocking concrete pavement, the importance of your bedding, your bases, and your sub-bases, also included your subgrade, and then recognizing your good practices. All right, so interlocking concrete pavement, or ICP. So let's just generally, what are they good for? And unfortunately, what are some of their disadvantages? So one of the really great things, and Danny had a really great presentation there that kind of really highlighted some of the good things. So we can do lots of fun things with them. We can do colors and textures and different layouts, and landscape architects love this because this is when they get to be really creative. So that's really great. From my perspective as a pavement engineer, I like that I know what we're getting. So I know that those blocks are manufactured to ASTM standards, as Danny said, so that they come and I know what we're getting. The problem with some of the other options of pavements, you don't know what you're getting until you actually get it into the field. So that's one of the nice advantages. We get these blocks delivered to us with high quality standards already in place. If you want to compare it against a concrete pavement, then typically over the long life cycle cost, they too tend to be cheaper than concrete pavement. One of the things I absolutely love, I did a major project on utility cuts. Utility cuts are the bane of my existence as a pavement engineer, because nothing hurts more than doing a brand new road and then having someone go in there and rip it up and put a utility cut in, where a paving project is really great because you can actually pick up the pavers, go down, dig, do whatever you need to do to your utility, whether it's installation or fixing it, put it back, and then you've got the pavers back in place, and most people won't even know what ever happened, which doesn't generally happen with concrete or asphalt pavements. However, there are some disadvantages, right? So some of the disadvantages are you really do need to have a contractor and quality assurance inspectors that know how to install these, right? And that's with any pavement, to be honest. You have to have good quality construction and quality control. They do tend to be more expensive in the initial upfront cost than a traditional asphalt concrete. Most of the roads, at least in Ontario and North America, are constructed out of asphalt. So you're competing against that. So we really want to pay attention to our detailing, our specifications, because if it goes wrong, they're going to say, well, see, it's too expensive. We can't do it ever again. So we want to make sure that we're doing proper design, construction, good materials, all that kind of stuff. Again, real special attention has to be paid to these kinds of things. And then on the maintenance side, we want to make sure that your operations and maintenance, for those that work in municipalities, they understand that they are different and how we maintain them are different. And we're not just going to throw cold patch in them if there's a problem with an area of the paver. So sometimes there's a retraining of city staff because it's not just how we've always done it. So those are all really key things that we need to keep in mind. Just a couple quick examples of some of the interlocking concrete pavements around. City of North Bay has one that's almost 40 years old. It's considered what we call a flexible pavement. I'll talk about what that is in a minute. It's sitting on granular base. It needs a little bit of maintenance, but it is performed really, really well. Mississauga, I live in Mississauga. This is the Streetsville Village Square. This was built almost a decade ago now. I can't even believe it's been a decade. This was dedicated to 𝐦𝐨𝐫𝐞, the longtime former mayor of Mississauga. And it is a paver project that is sitting on rigid concrete. It is being placed on concrete base. It is in excellent condition. Again, like the London Dundas place, it is now a place in Streetsville for people to come and gather. And it's a great, great little place. Dundas Place, I use that example as well. I am born and raised in London, so very, very proud of this project. Dundas was not the best place to be growing up when I was a kid, so this is absolutely amazing to see. And again, as Danny described, you've got the wave mimicking down to the Thames River down there at the waterfront. Wonderful project, lots of neat things. I've got more pictures from that coming up in a few minutes. Now let's go Western Canada, Granville Island. It's constructed also in the 80s. Again, it's a paver project considered a flexible pavement on granular sub-base material. Again, excellent performance. Always, you know, as with most any type of pavement, there's always some additional maintenance generally required. This is a permeable interlocking concrete pavement, or a PICP, that I worked on in Alston Way, Berkeley, California. It was also constructed in 2014. It is excellently performing both hydrologically and structurally. We got hit with some maintenance we weren't really expecting. We understand the clogging, but it actually got completely filled with cigarette butts. So that was something that we learned and that we've since dealt with. But you can also see we use different color pavers here to signify the lane markings in this one as well. So this was another great example. And I'll explain the difference between permeable and regular conventional interlocking concrete pavement in just a second. All right, so let's really quickly touch on pavement design principles. There's really 3 principles, but really when it comes down to it, there's really 2. So the first one is what we flexible. That is what we see when we see a blacktop out there, asphalt, flexible pavement. The idea is it's meant to move. It's meant to be flexible. Then we have pavers fall into kind of what we call a semi-rigid, because the pavers themselves are rigid, but it behaves more like a flexible pavement. We treat it like a flexible pavement when we're doing design, so it's semi-rigid or flexible. And then on the bottom right, we have a traditional concrete or Portland cement concrete pavement. So really quickly, flexible and semi-rigid. We saw a little video there just previously. What happens when the load goes over a flexible? You get higher stresses right underneath the load, and then it filters down into the base and sub-base and into your subgrade soils. So when we talk about pavers or an asphalt, that's what we're talking about. You've got movement, direct high stresses right under the load. For rigid pavement or Portland concrete cement pavement, the load is spread out over the concrete slab. And there's various reasons why you would do one or the other. They have their advantages and disadvantages to each of them. In terms of design specifications, information, design tables, the ASCE, the American Society of Civil Engineering, has design standards for both traditional interlocking concrete pavements as well as the permeable interlocking concrete pavement. They are there available for you to use. They are really great documents. They are constantly being reviewed and updated on a 5-year cycle. Lots of great information in there to help you if you're looking for design guidance on either types of these pavements. All right, so just a quick kind of thing, and how we do work sometimes is we try to figure out what kind of base we're going to do under a road. So looking at this is just a kind of an idea of what we call an equivalent design comparison. So we're using the pavers, we're using the bedding sand, that stays the same. And then we look at various ways of what is going to support our pavement. So a traditional would be your base and your made out of granular materials, your base and sub-base, that's on the far left. Or we might do an asphalt treated base, an ATB. In this case, we can actually make the total pavement thickness a little bit shallower. Cement treated base, we can actually do asphalt concrete underneath. We can do porous concrete. We could do porous asphalt underneath. We could do lots of kind of different things, and we can do some grid products as well. So what we try to do as designers is try to come up with what is the best way to do this. Now, there's pros and cons to some of these, because a base and a sub-base type material underneath is generally cheaper. However, your excavation depth will be deeper. Whereas if you use an asphalt treated base or cement treated base, you might be able to make your pavement structure shallower, but there's a higher cost. Now, asphalt treated base, cement treated base, anything that's got a more stiffer layer at the top might help you if you've got support issues or non-uniformity, which I'm going to talk about in a second. but they're more expensive if you say have to dig into a utility, right? If you've got to pull up the pavers, dig into a cement treated base, and then work on your utility, it's a lot more expensive to fix that than on a traditional granular base or sub base. So there's always pros and cons to each of these, and we try to use them wherever the site conditions require. There are hybrid products available to use in different forms of pavers and different things like that. Again, the structural grids that we've seen, those kinds of things, lots of different options out there depending on your site-specific requirements. So some of the key features of pavements, we've got materials, and this is really, really important. It starts right from the bottom. Your subgrade or your foundation, what is it sitting on? And we need to understand what it's sitting on, because then we have to design it properly based on those conditions. Then we've got our base and sub-base materials. We decide what we're going to use for that. Then we have our bedding and our pavers. And each of these all have to have details and specifications that need to be understood so that the whole pavement system works properly, right? And then once we've decided on the design and the materials, we have to make sure it gets installed properly. And this is always a problem in all construction. We need design, we need materials, we need installation, construction, and they all have to be working cohesively. So really important that installation is really, really detailed and paid attention to. Again, related to our subgrade, we want to make sure we have uniformity in our subgrade. Our pavement layers, are they designed properly? We're using the right materials, and drainage. And if you learn anything from what I'm about to tell you this afternoon, the keys to pavement design are drainage, drainage, drainage. You have to have proper drainage or the whole system can fail, with the exception of permeable pavements, which is something totally different. But we want to make sure that we have drainage, because everything can go really wrong really quickly if we let water in. Water is very evil to pavement engineering. So let's talk about subgrade. Subgrade is really important that we know what it is. We can estimate it, but we would really like to know what it is. So one thing we want to make sure, do we have consistent subgrade down there? And then when we are dealing with it, we want to make sure we're compacting it properly. We do not want areas of non-uniformity. So we don't want a pocket of clay beside sand, or we don't want a frost susceptible material mixed in with other subgrade types. And we want to make sure it's compacted. Pavements generally rise and fall with temperatures, particularly in anywhere that's susceptible to frost. If it all rises up, we're happy together relatively, but if it starts rising and falling at different times, that's when we can get into trouble. So we want to make sure that our subgrade is strong and supporting our work. We want to make sure there's no deleterious materials like clay balls stuck in it, soil, organic material, none of that. Again, we want consistency, and we've got to make sure the water gets out. Water in clay or silt is absolutely detrimental. If it's a sand subgrade, great. It's usually free draining. We're happy with that. If it's sitting on bedrock, we have a lot of problems in Northern Ontario with bedrock. Water can get trapped. Water expands in freezing conditions and can deteriorate your pavements very quickly. Pavement, the actual layer materials, I'm not going to go into details about these. There's lots of specifications out there to help you determine which materials are required for your base, your sub base, all that kind of stuff. The biggest thing we want good quality aggregates, durable. They're not going to break, clean, those kinds of things. So good quality aggregates is what we're looking for. Just a comment on equipment. We want to make sure we're using proper equipment for the proper jobs. Let's be using full, 5-ton rollers for roadways and plate compactors for, smaller areas, that kind of stuff. We don't want to be using a plate compactor on a major road, those kinds of things. So again, appropriate equipment for the type of work that you're doing in your site. Geosynthetics or geotextiles, different forms of that we can use in our pavements. Sometimes we use them for structural improvement, layer separation, filtration, separation, drainage, and waterproofing. Again, all of these are site specific. That's why it's very, very important. No two designs are similar. You want to know everything about your site, what you might need something like this for. So here's an example of separation. Again, I talked about uniform subgrade. Well, subgrade is really expensive to sub-excavate. So sometimes we have to find an engineering solution to deal with it. And one of those might be using a geosynthetic to provide a little bit more stability so that we don't lose our base and sub-base material into the subgrade, and then we start to get a whole bunch of problems associated with that. So separation can be used. This is a permeable application where we're using it to separate some of our layers just to make sure that our layers were staying where they were, because in a permeable application, we don't get nearly the compaction that we would under a normal pavement section. We've used them in cellular confinement type areas. This is Berkeley, this is Alston Way in Berkeley, California. And when we got to the tree roots, we couldn't sub-excavate near the tree roots. So we had to bring the pavement structure a little bit thinner. So we use cellular confinement around the tree roots in order to protect those trees, but also give us the strength required to support the traffic. It can be used on driveways as well. Here's an example using for structural reinforcement going up against a concrete foundation wall. It's a little bit hard to see, but here's just an example. So this is a paver sitting on existing asphalt. There might be, again, there's a reason why we might be using that as a base. We put a geotextile in there just to prevent bedding sand from washing away or infiltrating into the existing asphalt there, which is really important. We're going to talk about bedding sand with pavers in just a second. So I'm going to briefly talk about permeable pavements. So this is a completely different way to think about pavements now. And what this is this is a stormwater management best practice. And what we're doing is, in this case, the pavers themselves are not permeable, but the joints between them are. So instead of a sand between them to get your interlock, they're actually a different type of paver, and we put a joint filler with bigger joint filler stones with no fines in it, and the water filters through into our basin or subbase. Once it gets into our basin or subbase, we've got open porosity here. And this is our storage reservoir. And water is going to stay there for maybe 24, 48 hours, depending on our hydrological goals. And then either it's going to infiltrate into the subgrade, or in this case of this picture here, there's a geotextile, it's forcing it into a subdrain. And the point of this is to slow surface runoff down. So instead of going racing off the pavement into the catch basins, curbs and catch basins, we slow it down. Again, this is a stormwater management where we're balancing structural and hydrological things. So on permeable pavements, the materials look a little bit different. There's no fines. There's absolutely no fines. We've got our subbase here, big rocks, right? We want that high porosity. You're talking 30 to 40% porosity in your subbase. Then we've got our base material, a little bit more structural component, but still high porosity. And then we see our joint filler there as well. Really important in permeable, they have to be clean, no fines, because these types of pavements will get clogged. We don't want to start clogged. We want to make sure that we're getting the maximum porosity at the beginning. So we got to make sure that those stones are cleaned. And this picture was taken, and what's not shown here is when the water starts to drip off here, tons of soil and dirt were coming off it. So again, making sure they're really, really clean. When we're doing subbase and base preparation for permeable, it is different than if we're doing conventional pavers, right? So this time we do need compaction, but not at the same level, because if we over compact a permeable base or subbase, we will lose our porosity. So it's a balance between getting some compaction for structural, although maintaining our porosity. So again, very important that the contractor understands how to do these, the specifications are written properly, and that all the stakeholders for permeable pavements understand that this is not how we've always done it or how we do conventional pavements. Paver installation, it's for permeable or conventional is the same. Highly recommend some kind of mechanical installation. Obviously, it makes it more efficient. Health and safety of the workers involved. One of the beautiful things about pavers, there's no curing. Again, they come to site ready to go. So once it's ready, and we can open to traffic fairly quickly. And the nice thing about pavers, they can always be reinstated after repairs or if they're damaged. And back to one of the questions about paver supply, always make sure that you are ordering more pavers than is what is required, because you will need them to replace damaged pavers, utility cuts if you need them, those kinds of things. So always important to always have a little extra pavers on hand. Very, very important. For the permeable paver, the joint aggregate installation is really important. Again, we need it for that interlock of our pavers, but then we also need it to pull that water in through the pavement. So it's, as you can see, there's no fines. It's spread into the joints, compacted in, and then this has to be maintained. It has to be cleaned out and reinstated on a somewhat regular basis. Really, really important. At the end, this is just kind of a cross-section of what a completed permeable pavement would look for. So if you're used to seeing traditional pavements and traditional conventional, it looks very different. As you can see, there's no fine materials here at all. All right, so let's quickly get to some of the installation and detailing. I'm going to run through this. Again, uniformity is really important at the subgrade level, at the materials. We want to make sure uniform compaction, uniform materials. Otherwise, that can start to increase our rate of deterioration. Thickness design is really important. We want to make sure, are we designing for vehicles, pedestrians, understanding what is going to be using. That's our loading. Again, the materials for permeable and conventional are very different, so we want to make sure that we're using the correct ones. Again, uniform support for the pavement, really, really important. What are you building it on? What's your subgrade? I'm going to talk about some edge restraints are really important for pavers. We want to make sure that they have something that they can push against under loading and that they're not going to just slide away on us, right? Drainage, again, very important, both surface and subsurface, particularly really important for our conventionals. Again, water is absolutely detrimental to a pavement. And then how we actually install our paving units. This is a paver job that is on concrete. So the key with concrete here is we got to build a concrete pavement properly too. Concrete likes to be square, so we're going to make it square, or it will make itself square. So we make sure we put in the joints before, proper jointing of all the concrete, and then we put the pavers on top. Here's an example of where a geotextile was used between concrete and pavers. And we have to make sure that it goes down properly, or we're going to get some horizontal, we could get some horizontal shift. And in this case, this was opened up, and what had happened is it was not installed properly. It shifted the bedding sand, and then the pavers shifted around. And it doesn't look very nice. And, you know, you're losing that interlock, and it's now not performing as intended. Here's another example of our utilities. Utilities damage pavements, so we want to make sure that people have access to the utilities. So the more detail that we can put around our utilities is really, really important, because believe it or not, the utilities have the right to be there, although I wish they didn't, but they do have the right to be there, and they have to be able to access them to repair or install. So we want to find nice ways for them to get to their utilities. Again, this is just a picture making sure we got uniform practice of our bedding sand. Our bedding sand is so critical to these pavers to make sure that we get a good quality finished surface. So again, important that we are paying attention to details. Here's just a picture of mechanical installation. Again, it's efficient, and on the health and safety of our workers, really, really important. So here's an example of some pavers around utilities. We see these are really good cuts. The picture on the left, we typically recommend you don't use anything less than 50% of the whole paver. I know that that is sometimes not possible. We want to try our best to minimize small pieces of pavers. So on the left is a really good example. On the right, you can see we've got a little bit smaller here. We're getting some damage to them. Again, making sure we always have extra pavers to replace these damaged ones, but smaller pavers can be damaged really easily. Now, here's an example of a not very great one. We see a little piece there. The problem with that little piece, it can be pulled out easily under traffic or by hand. And look at all that area for water to get in. And once water gets in, that's when we're going to have some problems. Here's another example where they didn't even bother to put the pavers close to the utilities. Well, you might as well just put a big sign saying water come here right now. So water's going to infiltrate into that right away. Those pavers are going to start to move. It's going to wash away bedding sand. Here's Dundas Place again in London. We can see the detail around the utility cut cover here is perfect. It's a concrete collar, nice paver cuts. Again, not all of them are perfect, but again, minimizing small cuts is best as possible. Really important subsurface drainage and surface drainage. These are both pavers. You know, water is going to sit there. It's eventually going to, even though they're considered impermeable, it eventually will infiltrate into the system, potentially washing away bedding sand, getting into our sub-base space, all that kind of stuff. Again, increasing our rates of deterioration. Here's an example of bedding layer drainage. So we've got actually plastic pipes put in, really important just to help any water that will be gunning in get away. Typically during construction, these are covered up. Please uncover them before you put the pavers down so that we can actually use them as functional drains and not plugged before we've even started. We've had a couple cases of that. That's really frustrating. Really, really important. So here's what can happen if the water gets in. Example of washing away the bedding layer and the pavers just basically sunk. So they sunk down about 1 inch. Now we've got severe rutting in here and we moving into horizontal creep. Again, here we see some horizontal creep. The pavers are moving around. They don't really look very nice anymore. And now you're not getting your interlock. So you're going to have to start, you're going to start to get some failures. Here's an example of an expansion joint under, this is a parking garage underneath. And here's a pro tip from a pavement engineer. If you've got grass in your joints, you've got a drainage problem. If you can grow grass, you've got water. So really, really important that we make sure that we deal with the water. Here's just an example of some, this is for a permeable installation of subsurface draining. Again, we've put in that drain pipe. The idea is the water now stays into the system for longer, 24, 72 hours, and then goes into the drain pipes and drains away. Here's an example of non-uniformity support. So really important. This is a turning, I believe it's a drive-through. So the problem here is we've got slow turning movements, heavy loading, and it's just completely deforming that subgrade. So not great. Again, the pavers are moving. We've got ruts in the pavement. Not an ideal situation. Here's an example of edge restraints. Really, really important. On the left, we've got a concrete edge restraint. It's holding the pavers in place in case they, under loading, there's no movement. But on the right, there's nothing holding those pavers in place. So they eventually could shift and causing issues in your surface. Here's another good example of an edge restraint. Here's a concrete with a sailor course of pavers. Again, there's some small cut pavers there. It's not perfect, but much better than we've seen historically. That gives, extra stability. Those pavers are going to push up against that concrete and they're not going to go anywhere. What happens when we put pavers up against asphalt? They don't like each other. Concrete and asphalt do not like each other. They move and they behave very differently. So we've got movement. This is what happens. You can see we've got the hole, basically a pothole opening up, and that's just, again, water's going to infiltrate in there. That's going to cause issues on the asphalt side. It's also going to cause issues on the paver side. Here's one that's not too bad, but again, that joint is opening up, and eventually, depending on the types of loading, you get more heavy trucks in there. It's just going to push. It's going to crack that asphalt. Here's an example. These are permeable pavers that have been used. Again, Danny was talking about different layouts and colors and accessibility things. So we've got tactile walking surface there and different things. You can see nice curbs there for edge restraints. A little bit more installation detailing. You can put pavers directly on the concrete without the bedding sand. These are, again, make sure that the specifications are lined up, that the concrete's being built correctly, again, with your joints, any, those kinds of things. We just want to make sure, again, there's lots of details and information out there to help you if that is your desire. Again, units can be placed directly right on the concrete. Here's, again, some examples of some edge restraint options. They don't have to be concrete necessarily. So this is an example where it's butting in, it's anchored into the ground and moving to like a nice, beautiful sidewalk here with our large element pavers. We've got the concrete curb on the right side, but on the left side, we do have an edge restraint in there as well, holding those pavers so they don't move. If we get into the larger slabs, make sure that we're using proper equipment. Again, this is for the safety of your workers and speed and efficiency. These suckers can get a bit heavy. This kind of equipment has a 300-pound lift capacity. So I know I raced through that pretty quickly. There's lots of touch points because it's very, very important, right from the design to construction, specification, materials, all that kind of stuff, maintenance. It's all really, really important. But I just hope you learned a little bit something. If you will have questions, I'm more than happy to answer them. We can talk offline as well. But basically, why pavers are really great is they can provide high quality, long lasting surface. Again, you can move them and replace them. That's why I really like them. We want to make sure that we design them for appropriate traffic levels, site conditions. Drainage is very, very important. Always make sure that your transition treatments, your edge restraints, your curbs, your gutters, all those things are designed properly. And make sure that everybody involved understands, from the designers, the constructors, the QA, all that kind of stuff. Really, really important. And your maintenance. I thank you for your attention. If you have any questions, please let me know. Again, I can stay on for a little bit longer, or you can email me at lschaus@ara.com.
Wow, that's great. Thanks so much, Lori. That was very good, very informative. I know we're right up against it, but we did have a couple of questions. So if whoever wants to stick around and listen to them, that would be great. If not, thanks so much for joining us. So David writes, the biggest problem we're experiencing when using pavers on city streets is that all too often products become discontinued. That's a question for us. We can follow up with that one offline. It's just a question of availability. we had a question from Corey, who said, I've observed subsidence with unit paving installed around circular elements such as light poles and other small circular elements as many as 5 years after installation. Is there anything you can do to prevent this from happening? I know you did touch on this in your presentation. Obviously, a great fail-safe is concrete collars, but is there anything else that you could say, Lori, to expand on that? Or
concrete collar, any kind of concrete around it can be also really good. The key is really to minimize the little pieces, right? It's, you know, on some of those square ones I showed, they're like, they could have done a lot better around that. And the problem is it's the little pieces, because like, if you can go and pick it out with your hand, we're going to have a big problem, because if I can do that with my hand, then a car can go over it and pull it out really easily. To my knowledge, I don't know if there's any specific products. Maybe Danny might be able to answer that, but generally I like the collars. You know, the Dundas place, it also looks clean, looks very tight, and you can deal with that. And the problem is anytime these guys are going to get into those utilities, it's going to get a little bit messy. So there's opportunity always with utility repairs to fix any broken pieces, that kind of stuff, and reinstate. Not all, unfortunately, certain utility covers are manufactured the same way, but we know that, you know, small, big, they like, and then these guys go in and they just start cutting things. So it can be really challenging. That's where also information is really important, that everybody understands what's happening out there.
Great. That I was just going to jump in, David. Great point, Lori. And to touch on something you said in your presentation, and it kind of goes back to, there was a question submitted, and it was in regards to municipalities specifying our products or specifying a specific paver. And then, you know, a couple of years from now, when there's utility cuts and utility work being done, what do they do to match the pavers? And I like what you said in your presentation. And I think we need to get back to the basics. I think more product needs to be ordered, extra product needs to be ordered. And I know it's a difficult task sometimes to store it off site, but it makes a world of difference, because we see these utility cuts and they're patched up with asphalt, and it just ruins the whole pavement and the whole look of what the designer intended for that project. Just
yeah,
mention that.
Yeah, that's a really good point, Danny. And we're going to follow up with that on that question and figure something out there. One interesting idea for around light poles and utilities is something that Danny mentioned in his presentation. That's drive cell. You know, helping to spread out that load and create a little bit more of a stronger surface around those poles can also be something that we can look at. But we can follow up on a job site or a specific example if that'll help.
And just to touch on that too, one thing you want to be really careful with, and maybe not necessarily light poles, but things like culverts or things like that too, you got to really make sure that they are built properly, frost heave tapers, those kinds of things, because again, whoever's last in is going to get blamed. So the pavers are going to get blamed for something that might have been a subgrade issue and that kind of stuff too. So that's why it's so important that everything be designed, constructed properly. Because like if on a culvert, if you don't have that frost taper, you're going to get frost heave. I don't care what's on the surface. I don't care if it's pavers, concrete, or asphalt. You're going to have problems if you don't have that frost heave taper.
Drainage, right?
Yeah, that's all you need to know.
That's it. That's your middle name.
It's more than half the battle for sure.
Yeah.
Well, that's great. If there's nothing else from Danny, I think that we can safely wrap this up. It's been a great presentation from you both. Thank you so much for participating, Lori, and great job, Danny.
Thank you.
And hopefully we'll see you at our next presentation.